so much for being here with us for our session AI and Beyond Updates to the 2026 CSTA standards. While folks kind of trickle in, we're going to start off with a quick question for folks to consider and answer related to our topic. So, when I launch the question, you might get a little pop-up that asks you to allow or accept the use of Slido as a kind of polling tool during our session. So go ahead and accept that so that you can participate. I'm going to go ahead and start the poll now. And go ahead and respond. So the question is, what content should be most emphasized in the revised CSTA standards? All right, so you should be able to see the word cloud sort of populating that are based on everyone's responses. I see ethics coming in pretty strong, some design, problem solving.
AI seems higher rated as or more submitted as well as algorithms and programming. If you just joined, you should see an option to click open in order to pull up the Slido app in Zoom, and that will allow you to respond to some of our questions. So we have kind of a question that is, what content should be most emphasized in the revised standards? Thanks to all the folks who have responded to the poll. I see again that ethics seems to be the most common response, followed by AI programming algorithms, problem solving.
You should be able to see open in the chat. If you open up the chat window, that's where you should be able to go to open up um, Slido to participate. Thanks for all who responded. I'm going to stop this poll so we can move on to our next question, which is just asking what your primary role, professional role is. There we go. And while you're responding there, I'm going to go ahead and start sharing my screen. Okay, so about 40, a little less than 40% are curriculum PD providers. About a quarter of us are teachers, got some administrators and State Department of Ed folks, and some folks who don't kind of fit into any of those roles that are choices. So thanks so much for everyone being here today. Looking forward to getting your questions and hearing some perspective, and hope you enjoy the information we have to share. With that, we'll move on. Thanks so much again for being here with us for our session called AI and Beyond Updates to the 2026 CSTA standards. We want to start off by thanking our CS Ed Week partners for helping to make this content in this week possible. My name is Jake Caressel. I'm the K-12 Standards Project Manager at CSTA. I'm joined by my co-moderator, BT, and our esteemed group of panelists, Vicky, Justin, Jackie, and Jigger, and they'll have an opportunity to introduce themselves a little more specifically here in a bit. So our goals for today are to explain how AI is integrated into the revised CSTA PK-12 standards, identify other new priorities that are shaping the 2026 standards, and to plan an action step to prepare for implementation as we work toward launch of the new standards next summer. Our agenda is sort of cluster of different small presentations with review rounds and interactive polls throughout. So hopefully you'll be able to gather a lot of great information during our session here this evening. And now I'm going to turn it over to BT to talk about an overview of the standards revision process.
Thanks, Jake. Happy to do that. I'm gonna start by sharing like why we're doing this revision now. We're about 3 years in, or almost 3 years into a process, 2 years into the writing process, and it's a big effort. The reason we're doing that is because a lot's changed in the last 10 years. Our current standards were published in 2017. And since then, there's been a lot more students learning and interested at both the post-secondary and the pre-K-12 levels. There's been a lot of state policy adoption. That is the adoption of state computer science standards. There were only 7 states who had CS standards in 2017, and now 44 standards have those. That's a tremendous movement in policy. Those standards are mostly similar to the CSTA standards and one another, but they also have these interesting like differences to meet local needs. And so we work to examine those. Another major policy effort has been graduation requirements at the high school level. With a greater number of students, there's also like more diversity than ever before. And of course, there's been lots of advances in computing, notably AI, data science, cybersecurity, quantum, other things. And so these have driven us to invest in this revision process. And the revision is steeped in CSTA's vision, which is every student prepared for a world powered by computing. That's shown in the center circle here. We have identified these kind of scenarios or questions that students in today's world need to be able to answer. And their ability to do so rests on a strong foundation in computer science. Example scenarios are, I don't know if my personal data is safe. How can I automate something? How do I know if something is tracking my location? How should I think about AI regulation and policy? We believe that in order to thrive in the world of today and tomorrow, it's important for all students to have a strong foundation in CS, and that foundation is evolving. Let's go to the next slide. Our revision process is grounded in 5 values. These are centering equity, being generated by the community, looking towards the future and creating things that will both support that future-oriented vision as well as like last another 10 years until they're revised again. Grounded in research, and so we invested heavily in research prior to writing, and also flexible in implementation to consider the multiple pathways, school contexts, student differences for implementation. Ultimately, the purpose of the standards is to improve the quality of K-12 CS teaching and learning. We've invested in this process through 3 phases. We're currently in the writing one, but we preceded the writing phase with research. Research has consisted of the Reimagining CS Pathways project, where we work to define what CS content is essential for all high school graduates to know. We also work to develop pathways for students to learn beyond the foundation and connect those to post-secondary opportunities. The structure of the standards and much of the content comes directly from this community generated project. Other research efforts included the following. We compared state and international CS standards. There are 44 states that have CS standards. That's over 10,000 records. And we also looked at 6 other nations and their CS standards or curricula. And then we sought to look what is similar and what is different. What can we learn from that? We conducted with our West Ed partners literature reviews on a number of topics that inform the development of our concepts. And so those included algorithms, programming, data analysis, cybersecurity, and history of computing. We also conducted a comparison of the current CSTA standards to other sets of standards and frameworks. Those are both CS related, like AI, cybersecurity, as well as non-CS areas like mathematics, English language arts, the uh, visual performing arts, etc. We conducted a project we'll touch on a little bit more called the Identifying AI Projects Priorities for All K-12 Students, along with AI for K-12. And finally, we conducted a project called Amplifying Social Impacts of Computing Standards with some experts who dove deeply into impacts and ethics specifically and guiding how we can do this at the K-12 level. We have finished the research process just this year, but we started with the writing process almost a year and a half ago. We have kind of three groups contributing to the writing. The core group is a writing team that involves mostly educators. It's an incredibly experienced group of 24 individuals who meet together in person um, every quarter, and then they meet virtually really frequently. They're the ones who are responsible for generating the ideas, drafting the standards, responding to feedback, developing the content. We also have a team of technical writers and partners who contribute towards this and work to polish and refine. We have an advisor or a set of advisory board members that span state CS supervisors, as well as PD providers and folks across all roles in the community. And throughout this process, they've helped kind of guide the higher level and answer critical questions and provide regular feedback. And then we also have a large group of reviewers, and we invite you to join this, who provide feedback, detailed feedback on drafts of the standards. And we're about to release our third draft. Our next phase that we're getting ready for is publishing, where we will share both an interactive web display as well as multiple versions of exports. Those will be PDF and spreadsheets, designed printable versions, and that will include front matter, glossary, supporting chapters. Supplementary resources will likely include exemplary lessons, interdisciplinary integration guidance and examples, and implementation guidance for different audiences. It will also include teacher PD and state support. Here's what that timeline looks in a different format. So as I mentioned, we began writing about a year and a half ago, and we're wrapping that up now. We're proceeding a feedback period that will span December to January, and then we'll work in early spring to finalize the standards, and then publish and share the final standards this summer. We'll release at the CSTA annual conference.
All right. Thanks, BT. So with that, we're ready to dive into our first panel round. So we have a question, same question for all of our panelists. And that question is, what's a compelling new priority in the revised standards? And why does it matter for classrooms today? And I'm going to ask Jackie to first give a brief introduction of herself and then kick us off with her response to this question.
Sure, yeah. My name is Jackie Coricelli. My day job is working in West Hartford Public Schools as a computer science teacher and a computer science curriculum specialist. I'm involved with CSTA in lots of different ways. I always say that CSTA believed I was a leader before I did. So, nod to CSTA. I appreciate the whole organization so very much, and I feel so honored and happy to be part of this. The thing that I think has been the compelling new priority, at least from the high school level, and I should say that the role I'm in is the high school team, and that includes our specialty standards, which are beyond foundation. But different from the 2017 standards, we pointed all the standard toward what is a foundational skill that all high school students should graduate with. And that was a compelling new priority around which the research work that fed this, the Reimagining CS Pathways, and around which the way that we designed pre-K all the way through middle school and high school, what did that look like, was imagining very much. We'd often say, what is a driver's license? What do all students need to know before they graduate to be prepared for this world?
Thanks, Jackie. So yeah, really kind of building off of that work from the Reimagining CS Pathways project and thinking really thoughtfully about what does every student really need to thrive in that increasingly uh, technology-driven world. All right, I think we'll move to Jigger then, as another member of the high school team. Again, Jigger, give us a quick introduction and then what your response is to what's a compelling new priority in the revised standards and why does it matter for classrooms today?
Good evening, everyone. Jitendra Patel, I'm the Director of Innovation and Special Projects at Tuscarora Intermediate Unit 11, which is an education service agency in central Pennsylvania, really rural. And I support 9 districts in our region and help them implement computer science as well as do professional development, not just in computer science, but STEM and so on. So for me, the X plus CS, which is sort of a new focus, a new area, is really important. And as Jackie said, that there's that foundational, which is more like a driver license. We have specialty, and then X plus CS is really a way, as technology is more and more embedded into all the different subject areas. It's important for students to be able to connect that work back to computer science. What they're seeing in biology needs to connect back because there's a lot of technology being used in biology. And so, in order for them to understand some of those concepts, it's important that there's some cross-curricular connections, and X plus CS focuses on making sure that students are seeing that connection and seeing, how it works, not just that there's a connection, but they're exploring and going in depth and trying to solve problems and understand why certain things happen a certain way, especially with technology being embedded in those content area. And so for me, that's a really important thing as I work with all grade levels. And for me, I would I already see that there's connections, but teachers aren't always given the opportunity to sort of embed them in there. And X plus CS gives them the opportunity, not only computer science teachers to work with other content area teachers, but also those other content area teachers who might be interested in exploring more. And now they have some sort of a framework, some sort of a standard to sort of look at and say, oh yeah, look, I can cover that based on this standard that's available. So that's what I'm looking forward to, and that's what I'm very much excited about with the new standards.
Yeah, and so just to kind of reiterate for everyone, so we have foundational standards for all students that we're defining, and then we have a few different sets of specialty standards that are for continued learning beyond the foundation. And X plus CS is really about sort of applying the foundation into a variety of other disciplines. And so, Jigger or Jackie, could either of you give an example of what maybe that might look like in a school?
Yeah, actually, I can sort of one of the standards that we have for X plus CS as an example is assess how well algorithms solve problems within a non-CS discipline by analyzing their accuracy, efficiency, and relevancy to the intended goal. So you can see with that they can really explore the inner workings of an algorithm that relates to a particular topic area or particular subject area they're focusing on. So again, just going with biology or even music, like for example, right? Because that's one that's sort of a subject area that's not one of the core subject areas, but it's an important subject area. And so with music, there's algorithms everywhere with music, and so how can that student sort of connect the two topic areas together? I don't know if Jackie, if you wanted to add anything additional.
Yeah, I think one of the coolest things I learned about in ELA was that did you know that certain words go along with certain tones in poetry or in reading? And so a neat application would be to take all that data, that is that literature or that poetry or all the poems by a certain author and notice the tone patterns or the lingual patterns that kind of go along with either that poet or that feeling that and so that's a really beautiful connection and notice again like Jigger said it's beyond the foundation. A student needs to have some CS skills and combine that with a passion for another subject and it's really beautiful. Yeah.
Awesome. Thank you both. With that, let's move on to Justin. Justin, again, brief introduction and what's a new compelling priority from your perspective and why does it matter for classrooms?
Yeah. Hi, I'm Justin Kennedy. I work at the Northern Lights Collaborative for Computing Education, based out of the University of Minnesota. I do learning experience design, so basically um, curriculum, professional development, and with CSTA standards writing, I lead the middle school team, and the compelling new priority, and I don't know that I see it as a new priority. I see it as something that has happened, but I think with what we have done this time has been very intentional about um, looking at the progression every step of the way. And so vertical progression and horizontal, whichever way you want to look at it, from K to 12, looking at how the standards are building on each other and both level of knowledge when it comes to what we're asking students to do, we're asking teachers to teach, and then also the other way across within the same grade band, making sure that those skills are basically concurrently being built at the same time and not having different chunks in different areas and it feeling staggered. So a very holistic way of thinking about it. Um, it's been fun being in the middle school because I we get to like look at what elementary has done and look at what high school has done and then see where we can tweak the standards that we've been working on to kind of bridge the gap between the two and in a thoughtful way. And so it's it sometimes we're the go-between, but it's the team that we have is really excited about being flexible. And I think that just comes with middle school territory. So
Awesome. Thanks, Justin. And last but certainly not least, Vicky, give us a brief introduction and what's your compelling new priority you'd like to highlight?
Oops. I'm Vicky. I'm from California. I am officially a retired elementary computer science teacher, but I've been told I'm a poorly retired person. Um, I have been involved with CSTA for many, many years. I was a writer on the 2017 standards. I was a K to 2 grade band lead on AI for K-12 initiative, and I lead the elementary team on the revision right now. Um, I'm going to get a little bit more specific. We've gone very broad, but one priority that I was very happy to see um, that hasn't been explicitly addressed before is about reading code. As an elementary educator, I know that reading and writing go hand in hand, right? They help one another. The better writer you are, the more it can help you read. The better reader you are, the better writer you can become. But in CS, we always seem to emphasize the writing of code and not the reading of code as much. So while reading code was implied and even needed to meet 2017 standards, it wasn't explicitly called out. And for anyone that was new to teaching CS, it may not have been a priority because it wasn't explicitly called out. I've always felt we should emphasize reading code more. And in this day and age, I believe it even more. As AI coding assistants become more mainstream, the ability to read and comprehend code is becoming even more important. Um, if our students are using generative AI in other subject areas, a lot of times even the platforms they use will tell them, make sure you verify the output. AI makes mistakes, right? So what if we're having them use a tool to help them generate code? If they're unable to read and comprehend that code, they're missing that validation step. They're missing verifying the output of the AI. So I think it's become an even, you know, bigger priority than it used to be.
Awesome. Thanks, Vicky. And with that, we are going to take just a couple minutes to um, take a look at how some of the priorities all of you identified in our opening sort of poll question and some of the things that our panelists shared and see how those things translate into the updated organization and structure of the revised standards. So this graphic you see on your screen now represents the organizational structure that the writing team has been utilizing throughout the writing process. And like BT mentioned, is heavily based off of the work of the Reimagining CS Pathways project. We say it's easiest or best to read this graphic from bottom to top. So along the bottom are four what we call pillars, which are defined by bundles of practices that are integral to instruction and learning across CS concepts. And those pillars are ethics and social responsibility, inclusive collaboration, computational thinking, and human-centered design. The colored bands across the middle of the graphic are the concepts or the sort of buckets we use to organize the content of the standards. Those are algorithms and design, programming, data and analysis, systems and security, and computing and society. Several of these labels probably seem pretty familiar, and you might have expected. The biggest difference, probably compared to previous standards, is that addition of that computing and society concept, um, which really sort of encapsulates history of computing content, which hasn't existed in the standards before, as well as emerging technologies and humans and computing and career exploration. So several sort of new components of the standards are found within that concept. And then along the top, we have a set of 7 core CS dispositions, which are habits of mind that we hope students develop as they receive a high quality computer science learning experience that includes these 4 pillars and these 5 concepts. To go along with the high level structure, some other important key decisions throughout the process that will be helpful to know are that in terms of how the standards are written and organized, we did decide to have a band of standards at the pre-K and kindergarten level, and then discrete grade level standards at grades 1 through 5, which is different from the banding approach in previous versions of the standards. And then we have a band of standards in middle school for grades 6 through 8, and then a 9 through 12 foundational set of standards. So, which standards we think all high school students should experience before they graduate. And then 6 different specialty areas that range from AI and data science to physical computing and cybersecurity, and that set of X plus CS standards that Jigger talked about a bit previously. We aim for about 15 standards per grade. And so that would be sort of multiplied in a band like in middle school. And then the writing team's aiming to develop a variety of supplementary resources and guidance and has established some criteria for quality standards. So hopefully we see good consistency throughout. And then lastly, our implementation assumptions that we're making as we write the standards are that elementary students would receive somewhere between 20 and 40 hours of CS instruction per year. Middle school students would experience the equivalent of a year-long course at some point during their middle school time, and the high school students would experience the equivalent of a year-long CS course. And with that, I'm gonna turn it over to BT to talk about integrating where AI shows up in this structure.
Thanks, Jake. So you may have noticed in that structure diagram that Jake showed, AI wasn't present. So you might be wondering, well, where does AI fit? And the short answer is it fits across all 5 of those concept areas, those colored bands in the middle. Let's advance one. Um, we our approach to AI and the standards was guided by a National Science Foundation research project that CSTA led in partnership with AI for K-12, specifically Dr. Christina Gardner-McCune and Dr. Dave Turetsky. Our goal was to define what is key, what are the learning priorities that all students must learn around AI as part of foundational computer science. And the outcome of that project is summarized in this graphic. We define five categories for learning priorities. They're humans and AI, representation and reasoning, machine learning, ethical AI system design and programming, and societal impacts of AI. So then the writing team worked to figure out how this content defined here, these priorities, would be embedded into our existing structure. The main reason that we decided to not create a standalone topic for AI, but to embed was because of the complexity of actually like disentangling from those other things. Like it's really hard to talk about machine learning, representation reasoning without also talking about all these like important concepts around algorithms and data. And so what I think this points to is like the durable nature of the kind of key concepts and skills in computer science. And what we're doing is layering in to make sure that these AI priorities are present. To the next slide. We're using four strategies to make that AI content more explicit since it's not present in that high level structure. We've made it sometimes in the core standard, sometimes in the clarification materials for standard. We've added a machine learning progression within algorithms and design. We've added a humans and AI, or sorry, humans and computing progression in computing society. And we are also going to tag AI content in the web display to make it easy to filter or view. Here's a preview of what AI focused content is included within the various concepts. It's most notably in algorithm design and computing and society. In algorithm design, we try to broaden the rules-based algorithm approach to also include and balance data-driven approaches. That's where we have the machine learning progression, and there's significant societal impacts, such as bias, that occur here. In programming, we heard Vicky talk about the importance of reading code. I think one of the novel skills here is reading, evaluating code generated by AI. There's a lot around data. There in system security, there's security implications, environmental impacts. And then as Jake previewed, computing society, that includes history of computing, humans and AI, and emerging tech. And all of that has a strong AI presence. With that, we're going to bring our panelists back and want to think about this approach to AI. And we're going to start in reverse order. So let's begin with Vicky. And I'd like for you to share what should, like, why begin teaching AI in the earliest grades? And what does that even look like?
Um, this reminds me very much of the question and pushback we got years ago about should we teach CS to kindergartners, right? We often heard that back in the day. The answer was yes then about CS, and it's yes now about AI. We should definitely be teaching it starting in those earliest grades. Um, it's been yes about AI, about teaching about AI for a while now, actually. As part of the AI for K-12 initiative, we were talking about it back in 2018, 2019. But with generative AI, it's like even more important. Um, now, this isn't about teaching our youngest kids or youngest students about how to use AI, but how to recognize it in their lives, the impact it's already having on them and their families, and a bit about how it works because we don't want them thinking that it's magic. We want them to understand its algorithms, its people, its data. Um, so some specifics, well, if you think about all of our data standards and some of those in elementary talk about recognizing patterns and making predictions based on patterns that we as humans see in data. So it's a great place to start. We can talk about how machines can do that too, right? Here's how machines can learn from data. Um, as an elementary educator, um, I always believe books are a great place to start any content knowledge acquisition and things like that. And there are a lot of books actually available, fiction and nonfiction, that deal with AI currently. And I always recommend starting there as a really easy starting point. Um, I actually did a flash talk on this at last year's conference, and I'll stick a link to it on LinkedIn if anybody wants to learn a little more about some other ways I think about teaching this um, in to our littlest kids, starting even in pre-K.
Thanks, Vicky. You should go watch her flash talk if you've not seen it. I really like the concept of like just working to communicate it's not magic and like why that is. And I think that's part of our goal of like foundational CS more broadly. And I think it's especially true with AI where things feel oftentimes more magical, but are still very explainable and discrete phenomena. So I love that as like a charge. Thanks for sharing that link. All right. Next, we're going to ask a question to Jigger. Um, how are ethical and societal impacts of AI woven into the standards?
I think if you haven't already picked it up, you can sort of see some of that already in what BT talked about as well as Vicky talked about. We really thought about it as a very holistic approach to embedding some of the impacts, especially societal and ethical impacts of AI. And just as at an earlier age, again, as Vicky was saying, like there's this challenge of whether it's you don't want them to think it's a magical device. You want them to know that it's human created, and with human, there's going to be bias that comes in. And at an earlier age, as Vicky's example of just looking at pictures and asking the question, "What's missing?" And why is it missing in the data collection piece, and how does that have an impact when you use AI to make decisions? And so we've done I think as a collection, one of the things that we did was we sort of vetted all of these standards across different grade levels, but also different subject areas as with bringing our expertise in. And what that did was allowed us to sort of holistically embed impacts into standards across all of the topic areas. You don't just see um, ethical and societal impact show up in computing and society. You see traits of them show up in programming. You see traits of them show up in algorithm and design. You see traits of them show up in data and analysis subtopic and security. And so I think as a team, as a collective, we all know the importance of making sure that everyone understands that this is there, and we need to really talk about what the impacts are that we as humans suffer, but also how our environment gets impacted by that. And again, when you look at the actual standards, that the draft that we have, you'll see that it's across topic areas, across subject areas, and it goes well into the specialties as well. So we didn't just stop at the foundational level. We made sure that we covered some of those things at the specialty level as well.
A few things that I heard you say that I'll just like emphasize are that impacts are integrated throughout. And so one might also say in that high level structure that you don't see where impacts are. That's because it's a sub concept in many aspects. And we've broadened impacts to include, as you mentioned, like environmental concerns as well as like other harms, and used ethical framing for us to better understand or help students understand and like how they navigate this and think about that in position with like the technologies, in position with like the values and the people creating those for specific purposes.
Mhm.
Um, let's pause there. Jigger, thanks so much. Up next, I'm going to add Jackie, and I'm asked, what's one misconception educators often have about teaching AI?
Okay, so I've thought about this a lot recently. I am in my district. Our we run a whole AI team that's district wide to be able to help the district move forward ethically and responsibly using AI to help our students to learn. And so these misconceptions are front of mind right now for me. The first misconception I'd like to focus on is from the high school perspective. Oh, AI offers way too much math. It's going to be too difficult for our students to learn. We should not really touch about how does it work? And that is not true. We can teach AI as a black box. And we can even do a little bit of debugging before and after that black box without understanding all the mathematical intricacies within it. Beyond the foundation, for the students that might want to get into that black box, absolutely. But we can help our students to understand the most essential things about AI that they will need to know as consumers, and even as to some extent creators in our world, even without going deep into the mathematics that are involved. The second misconception that I run into frequently is similar to like what Vicky was discussing with what happened with CS about 10 years ago, that we are conflating the tool with the topic. Do you remember when a long time ago people thought, computer science and Word were the same sort of thing? Generative AI is one aspect of artificial intelligence. It's a pretty cool tool to have a learning language model that you can interact with, but that does not mean that by using it, you're understanding it. And so by getting outside of that black box and looking at the tool at arm's length, you appreciate, as Vicky said, even our older kids need to appreciate it's not magic. And in fact, there are some dangers if we look at it as just magical, because then we give up some responsibility to understand how it could be damaging in a lot of ways. And also some of the really great good things we can do, like scientific research that we couldn't do before it was created. So,
Thanks, Jackie. One thing I loved in the emphasis was like the distinction between kind of teaching AI content and using AI tools for teaching. And the standards mostly don't comment on using AI-based tools for teaching because that's about implementation, like how you get there as opposed to the outcome the students achieve. So we're specifying the learning outcomes, not the means to get there. Um, and so, yeah, that might happen, like that likely will happen, and there's important work to be had. But AI and the standards is much more about the AI specific learning outcomes, which is that distinction. Um, Justin, you're gonna help round us out, please. Our question for you is just like, what concerns came up as in development of these AI standards?
I like the what you just said about how to teach versus what we're teaching because that was pretty much, I mean, we have 30, 35 experts across the country coming in, writing standards and digging deep. And um, it a lot of it did revolve around, what tools are we going to feel comfortable with? Is this appropriate? Where's the divide? How can we teach AI in the elementary school space and some of the middle school space? And so um, a lot of those concerns came up just from the vast uh, experience we had in the group. A couple other of us also were like wrestling personally, like wrestling with the ethics and the responsibility and where we, landed on how we wanted to discuss AI within the standards, which CSTA did an excellent job of convening this other group of ASICs is the project, but how they came in and shared with us where ethics and social responsibility play in to computer science standards and how we can use that as a guidepost for development. So really across many things, but those were just a small snippet of some concerns that came up.
Thanks, Justin. With that, we're going to pause our second round of the panel here, and Jake is going to walk through and give us some example standards that are actually focused on AI. from draft three.
Yeah, so this is kind of a sneak peek. You can certainly dig deeper when we release our full draft for public review here in just about a week. But I wanted to share just a little bit about some of the AI specific content that the writing team's been working on. So this is the machine learning progression that is within the algorithms and design concept. And you can see starting in elementary school, we've got a separate uh, distinct standards for pre-KK and grades 1 through 5 here, and starting with grade appropriate sort of basic foundational knowledge around recognizing patterns and understanding how humans and machines can use patterns and learn from patterns and things of that nature. Moving into more sophisticated content and skills in middle school, and that investigating ways to improve accuracy of AI models, identifying and describing model features and limitations, to high schools justifying the selection of a particular algorithm or developing an AI model for a chosen task. I also want to take this opportunity to share some of the supporting information the writing team is working on uh, writing to support implementation of the standard. And so these next couple of slides will showcase those. The first is boundary statements, which really help to clarify what is intended to be included and not be included in a particular standard. And then alignment with our pillars and practices that are part of our high-level organizational structure. And as well as disposition that we should think about trying to develop through instruction in that particular standard. Vocabulary will be sort of interactively included in the web display and available as a glossary as it has been. And then also the writing team's working on identifying and describing implementation examples, which are ways that a CS standard might be implemented in a classroom, either computer-based or in an unplugged fashion, and also identifying interdisciplinary connections. So trying to identify some of the strong integration points with core content areas like math, ELA, and science, but also in other areas like fine arts or social studies and things of that nature. And then this is a sneak peek of that humans and computing progression. That's one of the sub-concepts within the computing and society concept. Again, sort of starting in elementary school, thinking about kind of the humanness of all of it and how humans have agency in making decisions around designing, developing, and using technology. Moving towards middle and high school, where we're sort of analyzing how human decisions have ethical and social impacts and debating perspectives on things of that nature. And I'm going to kick it back to BT to kick off our third round with our panelists.
Great. Thanks. So we welcome some questions from the audience. Feel free to put those in chat, and we'd love to consider some. Let's start with Vicky. I feel like one thing that Jake introduced, but we didn't explicitly talk about, was why are we moving towards grade level specific standards at the elementary level? That's in the past has been always grade banded.
Um, cool. Well, standards in other curricular areas are by grade level. So for me, the question is, why aren't computer science standards by grade level? We know that CS instruction is likely to be integrated into the classroom in elementary, so why wouldn't we give a fourth grade teacher fourth grade standards? So to effectively teach CS in elementary, if you want to teach it across all grades, it needs to appropriately build on knowledge and skills learned in the prior grades. Well, in order to do that in the past, states, districts, schools, teachers, and curriculum developers have had to do the work of unpacking the standard and figuring out what needs to be taught at each grade in order to get to that final standard at whatever the culminating grade is in the grade band. So we felt it was time for CSTA to do this work. And so that's why we're adding grade level rather than grade band standards.
Thanks. I'm gonna bring the others on now. And I like folks to lost you here. There you are. I'd like folks to respond to like, so we talked about some of the priorities and such. Can you share what you feel like is going to feel most different from the 2017 standards or common state adopted standards now? Like what excites you in that and like what feels most different?
I can go. I think I'm really excited, at least about the foundational structure that we have set up for standards. I think that we have established that everyone has an opportunity to be at the same level and same space throughout different grade levels. And we know that there are just systematic challenges for that. Some, just based on resources that schools have and whatnot. But I think what we have done is we have made it possible that if in an idealistic world, if a school had all the resources and they were trying to get everyone on that computer science foundational skills, has Justin talked about, like we purposefully have the progressions laid out in a way that it makes sense. It did, it wasn't as robust as before. I feel like now there's a more conscious effort on our part to make sure that it matches both vertically and horizontally. And I think to me, that's the most exciting part. That everyone can be at that same level, doing, when coming out of computer science with those core foundational skills.
Think the thing that excites me the most about the standards are the level of supports that we're trying to provide for everybody that's using them. We've worked really hard to develop more than just the standard itself, but like what does that mean is not included? Or what are some possible ideas for integration, which is like kind of my jam? Or where did this come from? Like what led to that? Or where does it go? And so there's lots of ways you're going to be able to interpret these standards to make them work for you and your students.
Thanks, Jackie. Justin, I saw Rick asked in chat now about like at what point do we envision students have using AI-based tools? What is needed before that? Can you respond to that one?
Sure. I think we've had discussions about that, and we I think as a group have to keep balancing the like what we're saying students should learn and then how they actually learn it. Um, I think, I come from a math background, and so I always think this has to be the point at which, whenever it was, where calculators really became a thing, and math teachers had to wrestle with like, okay, what do we cling to as the very basics and the very foundations of the field, and what can be outsourced to these new dang-fangled devices that all these kids are carrying around. Like that's, I think the what I feel is happening right now and what it seems to be um the trend. I think that because these coding assistants do fall into like a tool to do a thing, and the thing is programming, right? But because they fall there, I think we're a little apprehensive at this point to include wholesale within the standard. I could see, that being included in supplemental materials, that we have some advice or direction around that. Um, but I can't speak for CSTA. I just know our discussions that we've had.
Thanks, Justin. Because we're almost out of the time, I'd love for folks to just give a very brief last word of like what's something that you want to convey to folks, like one takeaway or call to action. Vicky, you want to kick off?
Um, okay. I the idea of revised standards can be daunting, right? Um, and many of you may be in states that you have your own standards, and you may be thinking, these will be great for those people who are going to revise the standards in the future, but I don't need to worry about them now. Um, but one of the things that I'd like people to take away is I'd like you to take some time and look at the standards and maybe find ways to extend what you're already doing within your own standards to include some of the newer areas that our standards have that your state standards may not have yet, like machine learning, explicitly reading and documenting code, and computing and society standards. They can connect to your existing standards before your state gets around to revising your standards.
Love that. Thanks, Vicky. Jigger?
Um, yeah, one takeaway is if you haven't take a look at it. You know, if you have a grade level that you teach, try to see how you can try out the standards. As I like to say, that this is a great opportunity. That's what I had an opportunity to do a couple weeks ago, and I found, and it was for an elementary group of second graders that we had in our space, and we took on the algorithms and design area, and I went through it and just looked at it to see how I would be able to do that. And one of the conversations earlier on that we had was, is this grade level appropriate? Is this age level appropriate? That was a lot of conversation that we had back and forth within our writing team. You know, like when is it appropriate to teach about certain topics and certain concepts? And I found that we have made it so we have set a bar really high, and I think um, there was some sort of pushback that this isn't grade level appropriate. But just when I tried it, it actually made sense, and the kids understood it, and the kids were the implementation ideas that we have, we took some of those and sort of try to implement them, and kids were able to do it on their own, and kids understood the concept that we were trying to get across in the grade band that we were trying to get across. So take a stab at it and see. There's going to be another round of feedback that's going to be going out, and so that's a great opportunity to try it out and let us know what's working and what's not working.
Perfect. Thanks, Jigger. Justin?
Was gonna say I that feels like Jigger stole mine, but like I think being able to just add your feedback is the call to action because we do sit there and go through most all of them, not really all of them. We do go through all of them, but having so many comments does allow us to really figure out what small things that we haven't thought of. And so I think that review process is very intentional. It may be painful, but it is very intentional, and we know it's for the greater good. So
Thanks. And close us out, Jackie.
Yeah, that CSTA is a great community, and you get to add to it by adding to this review. That together we are making these standards so much better, and we appreciate your input, and impact. It's late.
It is late. Thank you so much. Thank you to Vicky, Justin, Jackie, and Jiggers for both your leadership in the process as well as sharing your expertise tonight. And with that, Jake will help close us out.
All right. So just wanted to give a quick reminder of the timeline BT shared earlier. We are nearing the end of our writing process, about to gear up for our next big round of feedback before we really work to finalize the standards, language, and all the supporting information and prepare for publication in summer of 2026. Again, like folks alluded to, we would love to have any and all of you be part of our standards reviewer group if you're not already. So I think BT dropped the link in the chat. But essentially, next Wednesday, if you join the group, you should expect to receive an email directly from me letting you know that the draft is ready to be reviewed. So you can take a look at what we've pulled together and complete a review form to help us inform what our next steps are as a writing team. Want to take a moment to acknowledge all the folks involved in the writing process and research processes so far, including writers, advisors, reviewers, our research partners, technical writing partners, and funders as well. And hope you catch us for another CSED week event later this week. We've got AI in Action series tomorrow and AI Advocacy Community of Practice on Friday. Thank you all so much for joining us. Please let us know if you have any questions and hope you have a great evening and rest of your week. Thanks so much.